Okay, so this is the second video. Okay, so what's the energy stored in a capacitor? Well, we know that C equals Q over V, okay, from your capacitance formula. So, you know, charge per unit volt. And over here, or charge per unit potential difference. Here you've got Q equals CV, rearranged. So if we charge up a capacitor to a certain charge with a certain voltage, like if you put in 1 volt, then set the charges, put in 2 volts, set the charges, you could graph it here. You can get a nice straight line. Now the area under this graph, from our old formula for potential difference, work per unit charge, will give us the work done in charging it up. Okay. So what's the area under this? Well, it's just half VQ or QV. Now since V equals Q over C from the very start, you could substitute into this formula for V the Q and the C, so you get half Q squared over C. We can go further from there using Q equals CV again. Okay, you could put in for Q, for Q, CV. Okay, so you've got CV times V, so that makes half CV squared. Now all of them have the half. Okay, everywhere. Now what does that mean? Well, if you're actually charging up a cell, so charging up a capacitor, so you turn on the switch, current will flow and charge up the capacitor. Now as it does that, that's a capacitor, as it does that there's going to be Q leaving the cell or Q moving, and there's going to be a particular voltage, okay, potential difference. Those multiplied will give you the energy of the cell. However, we know that the capacitor is only going to have half QV. So it's only got half. So where does the other energy go? Well, it comes out as heat. Explain again. So remember, there's no resistance here around the circuit. So it's actually going to be quite a high current at the start. So as it goes around, there's actually going to be quite a lot of heat output as it charges the capacitor. So half is lost in the wires, half is stored in the capacitor. So for example, find the charge and energy stored by a 1000 microfarad capacitor when the potential difference crosses 6 volts. So using the formulas for Q equals CV to find the charge and half CV squared to find the energy.